Okay, here we go. Numerics response number 3. Haley is training for a race. Each day she runs 2 kilometers more than she did the previous day, than the day before. Okay, previous day means day before. If Kaylee ran a total of 21 kilometers in 3 days, then how many kilometers did she run on the first day? A lot of times it can help to draw a picture. I'm going to draw a picture here. Here's how far she ran on day 1. And then here's how far she ran on day 2. And here's how far she ran on day 3. By the time she gets to the end of it, she has run 21 kilometers. So it says she ran 2 more than she did the previous day. Each day she runs 2 more than the day before. So how about we do this? We don't know how much she ran on the first day. They don't tell us that, but she ran that much. So let's say she ran X kilometers. The next day she ran 2 kilometers more than the day before. The day before she ran X kilometers. 2 kilometers more would be X plus 2. So on the third day, she ran 2 more kilometers than she did on the second day. Well, the second day was X plus 2. If we add 2 more to that, that'd be X plus 2 again, which would be X plus 4. Does that make sense? So she ran X number of kilometers on the first day. She ran that same amount plus 2 more. Then she ran X plus 2 plus 2. We add the 2's together. We have 4. 2 more than the day before. So the total of all of these days of running, day 1 and day 2 and day 3, will all total 21 kilometers. So if we add all of that up, X plus 2 plus X plus 4 is equal to 21. Now we don't have any negative action happening here, anything, so we don't really need to worry too much about those brackets. I just put them there so we could clearly see we're separating that into those three days. But maybe I'm just gonna get mad. Okay, X plus 2. I'll just do this again. Try again. Plus X plus 4 is equal to 21. So like I said, if we were subtracting or something, those brackets would be important, but we're not. So just helped us to visualize. I'm just going to kind of get rid of those so I can see a little bit better. Okay, so I'm just adding. I'm going to collect like terms. I have 1x, I have 2 x's, I have 3 x's. So I'm going to add those together and I get 3x. And then I've got 2. I've got my constants. 2 plus 4, I got 6 is equal to 21. Now we can just solve this equation. So 3x, I'm going to bring my 6 over here. Since it's plus x, I'm going to subtract it to this side. So it's 21 minus 6. 21 minus 6 is 15. And then I'm going to get rid of this by dividing it to this side. So divide by 3. We're going to get 15 divided by 3, which is 5. Okay, so she ran 5 kilometers on the first. It said how much did she run on the first day? X is the amount she ran on the first day, so she ran 5 kilometers on the first day. And we can even just check that and tally that up. If she ran 5 on this day, she ran 2 more on that day, 2 more on that day. Does that add up to 21? 5 plus 7 is 12. 12 plus 9 is indeed 21. Okay, so we know we're good. All right, question number 22. Okay, again, I'm just going to erase this here because you guys can rewind and pause the video. It's a video. And it killed the radio star. Okay. Rid of all this nasty junk. Okay, use the following blah blah blah. Legend. Shaded is positive, unshaded is negative. So we talked about this before in class. We learned this year using algebra tiles in our workbooks that the positive tiles were unshaded and the shaded ones were negative. So this is the complete opposite. Now, I don't know if this is an old way of doing it. So maybe they changed that at some point and we're operating on the new way of doing it where the clear unshaded tiles are uh, positive and the shaded ones are negative. But for this question, we're going to have to just pay attention and realize that it's just the opposite on these ones, okay? But when you get a question like this on your PAT, just check whether what the legend says, if which one is positive, which one is negative. Would be nice if the positive or the shaded ones are negative, just so that we can work with what we're normally used to. But in this case, we're going to have to just think about what it's saying and be careful with that. Okay, so here we have a model. It says we've got a factorization of the trinomial represented by the algebra tile model above is. So when we have a polynomial, like I'm just going to make one up here, plus 5x plus, I don't know, 1. When we factorize something, a factorization is breaking it down into the two things that multiply together to give that other thing. So think about a number. If 6 is equal to 3 times 2, 3 and 2 are factors. This would be a factorization of 6. Okay, so it's just saying 3 times 2 gave me 6. So with a polynomial, we can have factors like something like these, right? These could multiply together to give us this polynomial. Now, I don't recall us talking about factorization during our workbooks, so this will seem a little bit new to you, but we can look at the diagram. We don't actually have to do like the algebra, right? Like we don't have to do the symbolic way of factorizing or multiplying those. So we can just look at, remember when we do these grids, it's like we can look, this represents the total thing, right? Like our product and we look at each side, that would represent the two things being multiplied together. Okay, so we could look at this diagram and see what it's telling us, what's matching. Okay, so when we're looking for the factors, we're looking for the two things that multiplied together to give us the one unified answer. So in this case, we're looking for what is this times this to give us this whole thing. So we're interested in what these two sides are. Okay, so if I look on this side, this would be like saying I've got, remember the long rectangles represent variables. So this would be my, in this case, negative, right? Because they said that, okay, so this is giving us, right, we have something times something here would have to give us this guy. So in order to get something positive, we'd either have to have, these are each worth 1, and this would be worth an x. So they either both have to be negative, or they would have to both be positive. So if I look at my answers here, I don't have any negative x's, so this would have to represent a positive x. And we said unshaded is negative, so this is negative. Then this would have to have come from multiplying. So it would have come from multiplying a, oh, unshaded is negative, that's negative. So this is positive, sorry. Yeah, it's hard to think backwards when we've learned it the other way. This is positive, and then this is negative. Those would multiply together, so this represents my -1. Okay, so I would have 3 of these negative 1s to make this picture here. So a po positive times a negative gives us a negative, right? Negative is, excuse me, is the unshaded ones. Okay, so we know if this is an x, a positive x, and here I have shaded, which in this case means positive. To get something positive, this would also have to be something positive. Okay, so this is going to be an x, a positive x. So an x here and 3 negative 1s. So this would be like saying x minus 3. Okay, and then on the top here we've got, so we know, we've got an x. I only see one x minus 3. It seems like A is going to be the right answer if I look down at my options, but let's try that out. They're saying it's x minus 3 times x minus 2. So if I use a minus 2, remember minus, in this case, negative 1s are the clear ones. It's like a negative 1, and that's a negative 1. So if we have negative 1 times a negative 1, that would give us a positive 1, which is shaded in this case. So that makes sense. So, and again, this negative 1, it's like a times table, right? And this negative 1 times this negative 1 would give us a positive 1. And then again, remember, shaded is positive in this one. So this all makes sense. That looks good. And then here, a negative 1 times x. So negative 1 times x would give us negative x. These long triangles represent negative x, right? Unshaded is negative, and a long rectangle is an x, right? This here is an x squared. These are negative x's. These are negative x's, and then these are the positive ones here. So let's just see if I can erase that without. There we go. So since we have on the top an x and 2 negative 1s, that's x minus 2. So these are the two things that would multiply together to give us the final product here. And they're not asking for what it is, but it would be, look, we've got x squared, and how many negative x's do we have? 1, 2, 5, 6. So we have, it would be x squared minus 6x. We have 1, 2, 3, 4, 5, 6 positive ones, and be plus 6. Okay, so this is what would happen when we multiply this and this together. We would get this guy over here. Okay, but they were just asking for the factors of this. They didn't even ask us for what that is. So our answer here is 22. Now, if you have any questions about that, totally understandable. This looks like something you're probably not used to seeing. So definitely come ask me if you need some more explanation on that. But hopefully that made sense for you. Okay, moving on. Two friends spent a total of 3.5 hours at various places in a mall as shown below. So they spent 3.5 hours total, and they spent 25% of their time at the food court, 43% of their time at the movie theater, 29% of their time at the shops, and 3% doing other stuff. Ask how many minutes did they spend in the food court? Okay, so food court was 25%. So we had 3.5 hours. We could do this in decimals or fractions. Let's say it's a calculator exams. Excuse me. So why don't we just call this 3.5? What's half of an hour? We could say 0.5, right? 1/2 hour. So 3.5 hours times 25%. 25% as a decimal is 25. So let's go ahead and pull out our calculator. Why not? 3.5 times 0.25 equals 0.875. Now that's saying 0.875 hours, right? Hours. But they asked us for minutes. Okay, so how do we convert hours to minutes? How many minutes are there in an hour? So an hour has 60 minutes. So we're going to multiply by 60, okay, to get the number of minutes. So we have 0.875 times 60. That's 52.5 minutes. And there it is, 52.5 minutes. Right? This was hours. Okay. Let's move on. Okay, so a playground is rectangular in shape with dimensions as shown in the diagram below. Here's the playground, 20 meters wide, 30 meters long. By how many meters must both dimensions of the playground be increased in order to double the area of the playground? Okay, so we don't know. Well, actually, we can calculate the area of the playground. It would be 20 times 30. So it's saying by how many meters must both dimensions of the playground be increased in order to double the area of the playground. Now we have to be careful. You're going to be tempted to just double everything, say that this is going to be 40 and this is going to be 60. But um, let's calculate and see if that works, first of all. I could tell you that it doesn't. It's not that. So we have, before we had 20 times 30, our original area was 600. So if we want an area that's double, that would be 1200. But how much, if we double this side and that side, we have 40 times 60, that's 2400. That's much, much bigger. So we can't just double the sides. Okay. What can we do though? We can think a little bit with algebra. So here is my original side. I've got 20 by 30. I'm going to increase this by a certain amount, and I'm going to increase this by a certain amount so that our area is doubled. Okay, so I don't know what that amount is. I'm going to call it X. And it said, by how many meters must both dimensions be increased? So we're saying that it's being increased by the same amount on each side. Okay, so if I increase this by a certain amount and this by a certain amount, I'm going to have a new rectangle. So here's my original area. Okay, and then I'm going to have a playground that has double the area. Okay, will look like this. Okay, so my new playground is 20 meters plus, oops, I should just use the same color there. So 20 meters plus X, right? Plus some unknown amount. 30 meters plus some unknown amount. Now, we know before that our playground was 600 meters squared. And our new playground is going to be double that, right? So our new playground is going to be 1200 meters squared, right? That's twice, 2 times 600 is 1200. So to get an area of a rectangle, we take this side times that side. Well, this is 20 plus X. We don't know what it is, but we're going to say it's 20 plus X times 30 plus X is equal to 1200. Okay, so